Hi, so today we're going to learn about thermodynamics. And enthalpy and entropy are the two driving forces of all chemical reactions. So enthalpy it deals with heat and thermal energy, whereas entropy deals with the disorder. So the basics of entropy and enthalpy, as well as thermodynamics, are laid out through the laws of thermodynamics. There are three of them. But the first one states that energy in the universe is finite and constant. So I think that this law is similar to the law of conservation of mass. Just like the law of conservation of mass, however, with energy can neither be created nor destroyed. So this means that energy just flows from the surroundings into the system, or from the system into the surroundings. And energy, thermal energy, can be found through the equation delta H of the reaction equals delta H of the products minus delta H of the reactants. So this law deals with enthalpy. And the second law of thermodynamics is with entropy, and it states basically that entropy of the universe is always increasing. So again, entropy is the disorder. So similarly to how most people's bedrooms, as time goes by, they get more messy, the universe also tends to get more messy through time and the occurrence of reactions. So delta S, which is how you write entropy, can be found through the equation delta S of the reaction equals delta S of the products minus delta S of the reactants. And then finally, the third law of thermodynamics basically states that as the absolute temperature approaches zero, the entropy of a perfect crystalline solid also approaches zero. So again, this law deals with entropy as well. It's stating that a perfect crystalline solid approaches zero. However, it's never reached zero. Scientists have unable, to date, they have been unable to make a perfect crystalline solid that is at zero when absolute temperature approaches zero. However, the entropy of a perfect crystalline is approaching zero, and it's very, very, very close to zero, and scientists are still working on that. So we have to tie in order to understand and be able to apply thermodynamics, entropy and enthalpy there must be a connection between them, right? So the value of delta G, which is the free energy change, basically tells whether a reaction is favorable. So when I say favorable, I mean that whether which direction, the forward direction or the reverse direction, the reaction is most likely to occur naturally through the process of time. So for example, I'll give you two examples. One, iron rusting is more favorable than iron unrusting. Similarly, it's easier to peel orange than it is to put the peels back together. That's why it's more favorable for the reaction when you're peeling to occur. So the delta G can be found through Gibbs equation. So this equation is delta G equals delta H minus T times delta S. Again, delta H is with energy, and delta S is with the disorder. So in order for a reaction to be favorable, delta G must be negative. And I've laid out the formulas for delta H and delta S here again. So again, delta H of the reaction equals delta H of the products minus delta H of the reactants, whereas the formula for delta S is the delta S of the reaction equals the delta S of the products minus the delta S of the reactants. So delta S is also multiplied by T here, if you can see right here, and T is the temperature. So the temperature is recorded through kelvins, and this is because kelvins is a standard unit for temperature. It's the SI unit. So now I'm going to lay out when delta G is negative, or when the reaction is favorable. So here's the equation again. Delta G equals delta H minus T times delta S, if you can see right here. So when the delta H is negative and when delta S is positive, delta G is favorable at all temperatures. So I like to think of this in math terms. So we're trying to get delta G to be negative in order for the reaction to be favorable. We're trying to not get it to be negative, but we're trying to figure out if it is negative. We're trying to figure out if the reaction is favorable. So if you write the equation by just writing out the signs, you can figure this out. So delta H again is negative, and then you're subtracting a positive delta S. So in order to figure out the logic behind these signs and why it's favorable, we can discard T, the temperature, because as I mentioned before, temperature is measured in kelvins, and kelvins can never go into the negatives. It's always a positive number, therefore we can disregard it just for figuring out whether it's favorable, just by using negatives and positive signs. So whenever you have a negative and you subtract a positive, it's always going to equal a negative, and that's why it's favorable at all temperatures. However, reaction is only favorable when delta H is positive and delta S is positive too, when T is at high temperatures. So the math behind this is that, so again, you have to write the sign for delta H, which is positive, minus the sign for delta S, which is also positive. So again, you can disregard the temperature right now. But if you can see here, a positive minus a positive can be it can be either 0, negative, or positive. In order for the reaction to be favorable, again, delta G has to be negative. So the only way that this reaction can be favorable is if this value right here, the delta S value, is larger than the delta H value. Or not just the delta S, but this whole value right here, including the temperature. So when temperature is high, this value becomes higher, and that's why it's negative. It's the opposite when both signs are negative, because whenever you do a negative, a minus a negative, it's gonna be almost like a negative plus a positive. So in order for this to be negative, the T value has to be really small. That way, the delta H can be larger than the combined value of the temperature times the entropy. And then finally, a reaction is never favorable when delta H is positive and T times when delta S is negative. This is because whenever you subtract a positive, whenever you do positive minus a negative, it's like adding a positive plus a positive, and that's never going to be a negative. Thank you for listening.